This lecture was organized by Alemi, and it is based in part on the book Open Intro Statistics. A random variable assigns numerical values to events within the sample space. The random variable x is shown as capital X. The probability that the random variable x has the value xi is shown here. The expected value of random variable is shown as the function e evaluated for the random variable x. The expected value of a discrete random variable is calculated by summing the product of the probability of the event times the value of the event. In this example, the charges for cleaning, root canal, crown, and post are shown for a dental clinic. The probability of a patient needing any one of these services is also shown. What's the average revenue per patient for this dental service? Note that the probabilities of these events do not add up to 1, as some of these events may occur together, so one might have cleaning and a crown together, for example. The expected value can be calculated by summing the product of the value of the event times its probability. The expected contribution of cleaning is $72. Root canal contributes $150 to the cost of an average patient. The contribution of crown is $240. The expected cost is the sum of each of the contributions. The expected cost for an average patient in this example is $500. A bookstore is expecting to sell the required textbook to 80% of students and an additional guide to 25% of the buyers. Note that the events have been arranged so that the probabilities sum to 1. 55% buy just the required book and 25% buy both the book and the guide. The expected cost for an average student can now be calculated by multiplying the dollar amount of sales with the probability of that sale. Think of the expected value as a point that would balance the probability distribution of the events. For the bookstore example, this occurs at $117.85. The variance of random variable x is shown as sigma squared and is equal to the difference of the value of the event minus mu, the mean or expected value of the random variable, times the probability of the event. In the bookstore example, we start with calculating the expected sales. We multiply the sales by the probability of the sale and add them up to get 117.85. This is the expected cost, or the expected sales. Next, we subtract from each value its expected value. Next, we square these differences. Finally, we multiply the squared differences by the probability of sale and add them up to get 3,659.3. The square root of variance is the standard deviation. In independent events, expected value of combination of variables is the proportional sum of the expected value of each component. Again, in independent events, variance of the combination of random variables is the square of the proportion of the variables times the variance of each variable. The take-home lesson for this lesson is that the expected value of a random variable is the sum of the events weighted by the probability of the events. See if you can answer this question.